Hi students, welcome to the video lecture on Pentium 4 processor. In the previous videos, we learnt about 8386 and 8486 microprocessor. In this video lecture, we will see the Pentium processor. It was introduced in 1993 as a successor to 8486. Pentium is also known as 8586 as it was the fifth generation of Intel processor. In this slide, we will see the generations of Pentium. The first Pentium CPU was introduced with 3.1 million transistors. The second generation Pentium was Pentium Pro and it was introduced in November 1995 with 5.5 million transistors and the clock speed of about 150 and 200 MHz. The next one is Pentium 2 with the 7.5 million transistors and the clock speed of about 266 MHz. The successor of Pentium 2 is Pentium 3 and it was introduced in February 1998 with the clock speed of about 1 GHz. The next is Pentium 4 and it was introduced with 42 million transistors with the clock speed of about 1.4 and 1.5 GHz. The features of Pentium 4 processor are, it is capable of carrying 64 bits of data. The arithmetic logical unit run at twice the processor core frequency and it consists of 20 stage of hyper pipeline technology. 8 bytes of data information can be transferred to and from memory in a single bus cycle and the L1 cache memory is capable of 8 kilobytes of data and L2 cache can handle up to 4 gigabytes of RAM. Hyper-threading technology supports in fast processor. It consists of 2 integer execution units and 1 floating point execution unit, and this Pentium 4 processor is capable of allowing execution of 2 instructions per clock cycle. Let us see the salient features of Pentium 4 processor. First one is superscalar architecture. What is superscalar architecture? The Pentium 4 processor has 2 integer pipeline. One is U pipeline, another one is V pipeline. The U pipeline is fully capable of executing any integer instruction, whereas V pipeline can execute simple instructions. So when a processor has 2 or more parallel pipelines, then it is said to be the superscalar architecture. Next one is dynamic branch prediction. Static branch prediction in general is a prediction that uses information that was gathered before the execution of the program, whereas dynamic branch prediction on the other hand, it uses the information about taken or not taken branches gathered at the runtime to predict the outcome of a branch. Next is the pipelining. Pipelining has 5 stages. The first stage is prefetch. Instructions are fetched from the instruction cache and aligned in prefetch buffers for decoding. The decode unit consists of 2 stages. One is stage 1, another one is stage 2. The stage 1 instructions are decoded into the Pentium's Intel instruction format, and branch prediction also takes place at this stage. In stage 2, that is computations takes place at this stage. Execute unit is nothing but the integer hardware executes the instruction and write back after the completion of the instruction the results are written back to the register file. The architectural diagram of Pentium 4, the functional units are bus interface unit, L1 and L2 cache, trace cache, instruction prefetcher unit, micro operation queue and microcode ROM. This is the modules of Pentium 4 processor. A fast processor requires balancing and tuning of many micro-architectural features. The Pentium 4 processor consists of 4 main sections of modules. They are in-order front-end, the out-order execution engine unit, the integer and floating point execution units, and the memory subunit system. Let us see the in-order front-end module in detail. The in-order front-end module is a part of Pentium 4 processor that fetches the instruction to be executed in the program. The front-end has highly accurate branch prediction logic in it. The front-end module has an advanced form of level 1 cache instruction called execution trace cache. The trace cache sits between the instruction decode logic and the execution core. The trace cache is capable of storing the already decoded instruction. The instructions are decoded and placed in the trace cache, and the instructions are taken for the execution from the cache like a normal operations. The L2 cache will be accessed when the machine misses the trace cache. The predicted instruction address from this front-end branch prediction logic is used to fetch the instruction bytes from the level 2 cache. The next unit is out of order execution logic unit. This is the unit where the instructions are prepared for the execution. The out of order unit has several buffers and it allows the reorder execution of the instruction. The out of order execution allows the instruction in the program to get executed as long as they do not depend on the other instructions for the execution. This unit allows the execution resources such as ALU and cache to be kept as busy as possible. The retirement logic unit is the one which brings the out of order execution back to the original program order. Next is integer and floating point execution unit. This is the unit where the instructions are actually get executed. This unit consists of register files where the integer data operand and floating point data operand are stores that are needed by the execution unit for execution. After the execution is complete, the result is stored in L1 data cache, which is used most for load and store operation. The last module is the memory subsystem module. This module consists of L2 cache and the system bus. This unit is responsible for carrying both instruction and data that cannot be fit in the execution trace cache and L1 data. Whenever there is a L2 cache miss happens, the external data bus is connected to the second level cache that is used to access the main memory to get the required data. And this is the comparison of microprocessor with respect to bus and memory sizes. So obviously Pentium 4 has a high capacity of data bus and address bus with a memory size of 1 terabytes. Thank you students. Hope you got the basic idea of Pentium 4 processor.